right, let's get started. Thanks for sticking around. You almost survived. You're almost done with MIX 2009, so appreciate you being around. In this talk, we're going to discuss RESTful services, and we will drill down on modeling RESTful services, keeping service interfaces on the REST side of things, and also I wanted to take the time to both spend like a fair amount of the talk on today's technologies, today's shipping bits that you can go use in your apps, as well as what are we working on for future iterations of the data services technology and technologies surrounding it. My name is Paulo Castro, and I'm an architect on the data group at Microsoft that builds effectively the data stack that spans AD.NET, the entity framework, data services, XML, and other technologies. So the way we're going to spend time today is I wanted to spend just a couple of minutes characterizing data services, and in particular, how data services fit within applications and application requirements, and also talk about the nature of data services out there. Then I'll spend a fair amount of time talking about the stack as it is today, how to use the AD.NET Data Services framework to build data services and to model them in a way that it fits naturally with the architectural style that we encourage, and at the same time provides rich services for your applications. And finally, I'll spend also like a reasonable amount of time, almost half of the talk, talking about both our short and long-term plans. What are we working on right now, and you'll actually be able to get your hands on very quickly, and also things that we're still in the early phases, but we're working towards. So with that, let's dive right in. So first of all, the first like characterization of services has to do with what are you doing with them. And if I look at all of the customers that we talk to that use data services, you can actually make an initial split that is actually very clear, and there's two main categories. There is one that is folks that want to build rich internet applications. These are folks building Silverlight or Ajax apps, and what you need once you cross into the Ajax or Silverlight world is now you're doing the rendering and presentation logic on the client, and the question is, how do you exchange data back and forth between client and server? These are typically applications where the client and server is designed together, and they are deployed together, and the focus is on ease of deployment. That's sort of the value prop of a web app, is that there is like friction-free deployment, and you want to keep those characteristics. And also the functionality itself surfaces through the user interface. This is an end-user application. On the other side, there is data-centric services. These are services that are servers per se, meaning they may have a UI, but in principle, there is a whole service head that applications external to the service actually use to interact with the system. You can think of examples that go from the Azure, say, the queuing service or the table service, to Amazon's S3 or SimpleDB, all the way to the application level where you have systems like Twitter or Facebook or MySpace that have APIs to talk to their system. These are different services in the sense that loosely coupling is actually key to these systems. You don't know who are your consumers, which OS they run, which tool set they use, which programming language, and so on. The key aspect is ease of access. You want to maximize your reach, and for that, what you want to make sure is that there is a low bar of entry into the system. And finally, state and functionality surface through the service interface, because in the end, there is necessarily no head, no interface to that service other than maybe the HTTP endpoint or things like that. So I would expect actually most folks to fall into the data on the RIA category, but I'm sure there's some on the other side. Like, do folks build rich internet applications like this? A few. Do folks build services at this at all? Do we have anybody in the room? One, two. Yeah, that matches actually our observations. There is a lot of folks building RIA applications, and there is a few building services. Usually services tend to be larger scale services, and there are service onlys, and RIA there is a lot, and there is varying scale from very small to very large. So the other characterization that is interesting is to look at them from the perspective of the nature of the interface. And since this talk is about modeling RESTful services, I actually looked at it from the perspective of how REST or REST-ish a service is. There is a lot of REST or pseudo-REST stuff out there, but I think the high order bit here it's not so much how pure you are, it's more about like how do you satisfy your requirements. And you know, if you have the requirements that come from applying the REST architectural style, then sticking to it usually makes sense and pays off. So on the RESTful side, the key aspect is the fact that both state and functionality are surfaced in terms of resources. So the only thing these things surface is resources, and they can be manipulated using what is called the uniform interface, which is a fixed, well-known set of methods or verbs that act on any resource in the system, and they mean the same thing regardless of which resource is acting on. And you know, it follows what in the REST write-up, the original write-up is listed as the REST constraints that have to do with being client-server, being stateless, and allowing for layering and caching and so on. On the other hand, there is APIs that are just web-friendly, and that's the goal. They may or may not be RESTful. The high-order bit in many of these is, how do I make sure it works well on the web, and any web client can actually interoperate with it? So usually they do very heavy use of URLs, not just for addressing, but in general for sometimes even the method names are put in there, and a lot of data is put into URLs. Tend to exchange simple documents using JSON or XML, and the sort of highlight here is the important thing is low barrier of entry. So with these two things in mind, what we're going to do for the rest of this talk is drill down into how to author RESTful data services using the data services framework, and how to bring all of the functionality typically needed for an application into the picture. So the way I want to do that is I assume that folks are somewhat familiar with the AD.NET Data Services Framework, and if not, there is a lot of content out there, including talks from the 2 previous years at MIX that will give you the Data Services 101. And what I want to do that is, I don't want to have everybody wait for me to do the basic setup again. So I'll start with a working service, and what I want to do is build on top of that the sort of the trickier and more sophisticated functionalities that typical real-world applications require. So I'm going to start by talking about what a service looks like. So when you create a service, and in particular when you create a resource-centric service, like a RESTful service, structure of the service is important. In fact, it's the primary way of describing a service, because the uniform interface says that the actions on the service are uniform and are well-known. So there's nothing else to describe other than the structure of the service and perhaps the side effects that are caused when you change the state of those resources. So let's dive right in and start building one of these services. So what I have here is, I have Visual Studio 2008, and I'm running Service Pack 1, which has data services out of the box. And in this case, I'm doing data services against a relational database. I have SQL Server on my box. So I have here a model. This is a pretty classic model. I have customers, sales order lines, which in turn point to products, categories, and I'll get to users in a little bit. So what I want to do is I want to create a RESTful interface over this model. The first observation I want to make is, like, there is a database in the system. That does not mean that your REST interface or your service interface in the more general sense has to fit one-to-one to the database. In fact, most of the time, you want a very strong separation between these two things, and you don't want database isms to permeate through the service interface. So I did a few simple, quick things here, like, for example, I pluralized entity set names, for example, to have more natural URLs. I renamed a few of the properties, and I'm using the entity framework mapping infrastructure to support all that without changing my database. So I want to do a couple more tweaks. So I have my model. The other thing I have here is I have a service. This is my bikes service. This is a bike shop. We sell bikes and bike parts. And this is a data service of bikes entities, which is my entity framework class. And this is where you're left off when you create the model, create the data service, and you point the service to the model. So we'll start here. First thing I want to do is I have some tweaks already done in my model. Now, what I want to do is I want to do further tweaks that are on the service, but I don't want to affect the model. The model is fine because I need it for the backend, like for the server implementation. What I need is further restrictions on the client. And for that, what I'll do is I'll use the entity set rights. Entity set rights allow you to say, I want a richer model on the server, but I want only a subset of it to be visible to the client. So what I'll do is I'll set the set entity set access rule. Like those of you that used data services are familiar with this. What a lot of people do is put a star here, meaning let everything do everything. Please don't do that. So let's do the real deal here. So I have a customer's entity set, and the interesting thing here is to take the time to think about how to take each one of these. For example, customers, I want everybody to perform every operation. I'll do more fine-grained security later, but for now, this is enough. Next set is the sales orders set, which I want the same thing, and actually, I want the same thing for the sales order lines. Now, we get into the product set. So we have a set of products, but this system is not a product catalog. I don't want people to go change my products and things like that. I only need them because I want sales orders to refer to them. So I'll set them to all read, meaning you can do any read operation, you can search products and so on, but you cannot go change them. And finally, I have a users set, and what I want to do here is, I don't want people browsing around users and such. I want each user to know that they can access their own thing, and that's it. Another situation where what I'm about to do is interesting is, let's say you have a lot of data in a particular entity set, and you are fine with people accessing any one of these items. What you don't want is people to write an arbitrary query that maybe ends up yielding sort of 10 million rows or something. What you want to do is, if you know the address, you go fetch it, but you cannot search around. It's not a security feature, it's just a way of restricting the interaction model. This is called read single. And what it means is, if you know the URL of a particular entity, you can fetch it, but you cannot browse around. Finally, it's interesting to look at the fact that I have a categories entity set in my model. Switch back here, this guy. But I didn't activate the categories entity set in my service, which means categories are disappeared, and that's fine, we'll fix that later. Disappeared completely from my service interface. So let's take a look at the model. What's failing is the other project, don't worry about it. We'll fix it once we do the client. So if I now hit the root of the service, I'm not going to drill down a lot on the XML isms here, but you can see that this is an Atom service document, which is what we reply by default. And you can see that there is customers, products, sales orders, and users, and there's no categories. So we removed categories from everywhere. All the relationships to category are gone, all the read and write paths are disappeared, and so on. So you only get the pieces that you're interested in. And also, it's not obvious from this document, but if I try to write to the product set, I will get an error. And also, if I try to hit users, I would only work if I hit a particular user and not if I try to browse around. Like, for example, if I say /users, which would return all of the users, I get an error. 403 means forbidden, means like you cannot do this, and there's nothing you can do to make it through. So it's not an authentication issue. And if I address a particular user in this case, once I hit the database, we should get the response back. Then this, weird. Okay, I'll fix it in a second. So this actually does return what I need. It's just that what I cannot do is write a query that browses around them. And we should figure out why this is not working, because otherwise it's not going to be a very fun demo. Let's try one more time. These bikes, users. I'll get back to it in a second. Actually, we can turn this into a debugging session in a second if that doesn't work. So the next thing I want to do now is I have a structure on the server, and it may be that this is being used for a client that, actually, I'm sure I have a SQL started. This, yeah. So this may be the backend for a front-end system that I own, maybe a Silverlight front-end or an Ajax front-end, or maybe a service that is exposed out there to other systems. In either case, if I'm using Visual Studio on the client, I can actually take advantage of the metadata system and retrieve metadata from the service. Actually, I know what's wrong. I'm sure I missed sales order. I'm sure one of these names is wrong. Customers is good. Sales orders, sales order lines, product, users. Users is good. I'll fix it in a second. So, what is that? I'm pretty sure it's users. No, it's users here. So what I did is I have the entity sets in plural, so I have like a nicer set of URLs. I'm just being lazy. Like let's actually do some. So we actually have, by default, we don't want to expose too much error information because we don't know who we're disclosing it to. But we can always do service behavior and say include exceptions in false equals true, and now we can actually know better what's going on. We also have, and I'm explaining this while I'm doing this. It was not planned exactly, but let's go here. We should take bets on this or something. I think this one is fine. Yeah, it's fine. I'm going to run it actually and see. Let's see. Now we'll see actually what's going on. Man. Unspecified error. That's not good. Let me do the one last thing, and then I'll just close and reopen if that doesn't work. Let's see. Bikes users 1. Okay, I'll just close and reopen. Before I go there, though, I want to highlight what I was trying to do, then I'll get back to it. So the goal here was to shape the service interface from the structural perspective such that it makes sense. Next step is now actually allow access to this from clients within my application or outside of the app. And I'll get to this next, and in the process, I'll actually fix the app as well, hopefully. So to recap, I think the single most important message I wanted to give around service interface is that the fact that we'll give you a flexible interface over the data does not make this a database interface. This is actually an interface that is designed for being a service layer, and it has to be optimized for the concerns on the service layer. So there is a number of things of the database that you don't want to surface through the service interface. So model is appropriate for that, and expose application-level concepts rather than database-level concepts. Like things like link tables, for example, are usually weird, and you want to remove them from the service interface. Same thing like when you think about latency and so on, you want to optimize your model for that. Finally, keep in mind that the schema as seen by the server does not necessarily need to be the same as the schema seen by the service. So, because you may have more code on the service that does things that you don't allow on the service. So you can control this with the set entity set access rights options. So next thing is, so now we have a service and we have a sense of the structure of the service. The next question is, who can actually access this service? So let's do this next. So, and we really need to find out what's going on here. So let's do this as an interesting debugging option to see if I got the names right. This is a feature. Come on. This is how you debug the stuff. Don't do this at home, yeah. Okay, let's resort to the last thing, which is, you know what curl is? Command line. It's a command line HTTP client. It works. So it's the browser that is giving me a hard time. Oh, I know what it is. There you go. Look at this. There. I'll explain this later. There you go. So, thanks. So now we can, so just to regain a little bit of credibility, let me undo this change. And refresh here, which actually shouldn't change anything. But now I can say this with a straight face. Like if you hit here, now you don't get the access because we prevent access into that particular set. So next thing I want to do then is, in this case, I have a Silverlight application. And what I want to do is I built most of the app already, except that I didn't build a hookup between the app and the service because I wanted to highlight that part. So what I will do is I will come to my Silverlight application and add a service reference. I could be using Visual Studio from across the web from this service and not even know the dude that owns the service, and this would still work, same experience. So I'll discover the service. This is my service endpoint. I can also take a quick peek at it if I want. I can see all of my entity sets. I'll call this bikes service. And so what this does is we will go fetch from the service, we will fetch the metadata document that describes the service, and then we will generate client code for you, so you have .NET objects to express your entities, you can write link queries against them, and we will do change tracking, you can push changes back to the server, and so on. So if I double click on this guy now, I have a generated namespace called bikes service. And inside, you can see there is the bikes entities class that represents the service entry point as a whole. And then I have a type for customer, for product, for sales order, and so on. So now I have my model on the client. There are no operations, though. What I have is the structure of the resources captured in types on the clients. So now that I have this, I should be able to build the whole thing. And I should be able to actually run it. Let's see. So I have a Silverlight, very simple Silverlight application, nothing fancy. And what happens here is I have customers, and as I click, at least some of the customers have sales orders, and sales orders have a sales order line. Let me show you the code for this real quick. So what I have is, when you first load the application, we call load data. And what load data does is it creates a new bikes entities, which points to the service. Since I'm in Silverlight, I can have a relative URL because I'm in the same page. And then I write a link query, which actually we turn into a URL, and then execute this against the server. And then as you select customers, I don't want to do SAML binding all the way, because I want to delay load the other piece, and I want to control how that happens. So what I do is, whenever the selection changes for the customer, what I'll do is I'll grab the current customer, and then write a sort of a reasonable link query that will go fetch the sales orders, and then prefetch the lines and the products. So in a single go, I can go to the data service and retrieve all these. And the cool thing is, although I have this nice link experience on the surface, under the covers, we're actually just using the URL conventions that the data services framework utilizes. So we have a translator from one to the other. So let's do this. I want to turn off exceptions so we can. There. So we can run through this. There. So I want to show you in particular the point where we run the query, like here. So I'll step over the expand. So this is a link query, but if I hover over it, this is kind of small, but you can see that we actually turn the link query into a URL. You following the convention that we have. So you get the nice programming model on your side, but under the covers, there is nothing proprietary. We're just using a simple RESTful interface, and the only thing we do is we have a URL convention that we tie clients and servers to. If you don't want that level of coupling with URLs, then you can simply blindly exchange URLs without using the link implementation. Okay, so coming back to the topic at hand, the question is who can access this thing? And an interesting thing to think about when you talk about authentication is who is your client? Is your client your own front end, maybe an Ajax or a Silverlight application? Or is it that your client is any client out there and you want to maximize your reach to all the clients in all platforms and so on? Depending on that answer, is that your decision framework will change a lot. So I'll give you one example of each so we can use it as a reference. So the first thing is you may want to say, well, I have an Ajax application and it's a website and I want to log in just like in any other website. So you can do that by using forms authentication. So I'll go to my web.config and I'll change my authentication mode. This is regular ASP.NET authentication. I'll change it to forms and I'll uncomment this, which will prevent anonymous users from logging in. And now I'm going to watch this page in the browser. So let's run the app. So now when we hit the Silverlight page, standard dance happens. We get redirected to the login page, and now here, in this case, I'm just using the membership providers. So this is like standard ASP.NET. So I'll say Pablo, my super secret password here. And once I'm logged in, then I'm back into the app. Now, look at this is the interesting thing. My code inside Silverlight just worked, and I didn't change it at all. So, since we are integrated into Silverlight, and we actually use the browser stack to talk to the server, the forms authentication, which is effectively cookie-based authentication, just makes it so that the cookies are set in the session, and then they are sent back whenever the data service runtime issues a request. So if you use forms authentication or any scheme of cookie-based authentication within the same domain, this just works, and all of the services should just work, like queries and so on. Same thing with updates and stuff. So of course, you may want to log in within your Silverlight experience. And in that case, we have a library, which is the .NET Client Services library, that ships as part, comes as part of the overall framework of providers for ASP.NET that allows you to log in programmatically and obtain a cookie. This works on Silverlight and actually works on .NET apps outside of the browser. Now, the other case might be that you want to reach as many services as you want, and interoperability is a high order bit for you. So in that case, while you could do this cookies dance, it's non-standard, it's kind of unusual, so you may want to opt for a more standard, more well-understood protocol for authentication. And there are many out there. An interesting option actually is doing basic. Basic on clear, of course, is unacceptable because credentials travel on clear over the wire, but basic over SSL is okay. And in many cases, it just solves the problem, and almost any HTTP stack can do basic authentication. So let me switch on basic auth. So let me comment this out. Whoops. And switch back this to known. So there is no built-in basic authentication provider in ASP.NET that uses the membership provider, but there is plenty out there. There is actually, I found a couple of good ones in Codeplex, so there is a number of ways of doing this. What I did is I hooked up one, and I'm controlling it with this switch so we can turn it on and off. So by saying on, all I'm saying here is I want all traffic to be authenticated using basic authentication. So let me navigate to this page again. So let me actually, this is not very fun when you look at it like that. So let's open a new browser. You're not supposed to see the back, right? It was the previous page. So if I do this and walk into the browser, into the site the first time, I get this dialog. This is not, from a web experience perspective, this is not great. So usually for web sites, you want the integrated form experience. Now, if I log in, you still get, well, if I log in with the right password, you still get the rest of the experience, and in fact, the data services client will pick up those credentials and use them. Not because we do anything about it, but just because the browser stack works that way. So I wouldn't go with this if I had a website. I would actually do something like forms authentication. But what if what you're trying to do is not a website, is to reach as many clients as you can? So let's do that. I'm going to use curl. Curl is an HTTP command line client that is part of libcurl, which is also a library for doing HTTP. And what I'll do is I'll use this as an extreme example of interoperability. Your life is probably better than this in most programming languages and environments. So let's say I want to know all of my customers. I can say curl, and then I can say user Pablo, and this is my super secret password I was talking about before. User and password, and since I'm using standard basic authentication, this will just work. And then I can say what I want to do is a get, and the URL I want to retrieve is slash. So this bikes, and then let's say I want the customers, so I want this URL. So here you go. Then you're supposed to parse this or do something interesting with it, but we get all the customers. And I can even do things. Let me make a small request. You can even control, like, for example, the output. We use standard HTTP content type negotiation, so I could say the accept header, what I'm willing to receive as a representation for this resource is, for example, application/JSON. And this time I get the representation in JSON instead of XML. So I'm relying on standards to specify content types that I'm willing to understand and to specify authentication. So this maximizes my reach, the number of clients I can interact with. And there is a trade-off between the two. And in general, if you need both, because you're both a front-end system, or you have both a front-end system and a service interface, in my experience, the easiest thing to do is just to have two service heads, because they, authentication schemes tend to conflict and they cause a lot of trouble if you don't. So to recap on access, you need to think about the scenario you're targeting. For Ajax, Silverlight type of applications, usually Form does really well. Or this even works on .NET outside of the browser, although it's non-standard. If you have a wide open RESTful service, then if you go to lengths to have a clean RESTful interface that maximizes interoperability and being a good citizen of the web, you may as well go with standards for authentication purposes as well. The last thing I didn't mention is integrated authentication actually works really well within companies. So if you have a company that has NT domains and uses NT logins for applications, it works with the data services client, it works transparently, and you get a very, a safe, secure experience that doesn't require secondary logons. So within companies work well, across the web, not so much. Great, so now we have a service that has a shape, and also we secure the service. So we know who is logged in if they could log in. The next question is, what can you do with the server? Or in general, given who's logged in, what are the operations that he's allowed to do? And also, what are the records that a particular user can see? Because sometimes it's not about doing a whole class of operations. It's about over which resources you can act. So let's talk a little bit about how to model access control using a RESTful interface with data services. So we're going to come back to our little Silverlight application and also back to Visual Studio. So what I want to do now is I want to establish an access policy, an access control policy. And here's how my particular policy, for this example, looks like. I have customers, and I have my user table. And what I want to say is there is a link table. You can see this is a many-to-many relationship. That means at the database level, I have a link table that has the user ID and the customer ID. And what I want to say is you can see any user that is in the link, any customer, sorry, that is in the link table. So there is this link table that is literally an access control list. It says for this customer, this user can see it, this other customer, these other users can see it, and so on. And also, the policy that I want is that if I can see a customer, I can see its sales orders and its sales order lines. So I want the policy to chain through my sort of dependency graph. So let's implement that. I'm going to go to the service, and I'm going to use a construct called query interceptor. Query interceptor allows me to sit in between the query pipeline that we use in the data services framework and intercept the calls and inject custom predicates. And what I want here is exactly a custom predicates. I want to inject a join with the user access control table. So let's do that. I'm going to have a query interceptor over the customers set. And so interceptors have this funny looking thing. Believe me, you get used to it over time. At first, it's kind of a shock. Where you have to return an expression of function of, which means we want a predicate. So a predicate is a function that goes from the entity type, in this case a customer, to Boolean. So that if it is true, we include it. If it is false, we don't. And we need that in expression tree form. So that's why it's an expression of function of something. And this something in this case is customer Boolean. And I'm going to call this on query customers. So first thing I need to do is I need to find out who's logged in. So I'll go string user equals HTTP context. In this case, I know I'm running on ASP.NET. You can use also the operation context in WCF if you want to run outside of ASP.NET. And I want to say user.identity.name. So this is a login name of the dude that is using the site at this point. And now I want to write a predicate that filters the customers that this guy can see. So I'll say return a predicate that says, given a customer C, make sure that there is at least, look at the user access list, which is the relationship between customers and users, and make sure that at least one of the user's records there is such that the login name is the user that I have. Does that make sense? So this is literally a join between the user table and the customer table and the customer user table. So now let's compile this, and let me open the access table here so we can take a look and change it as we go. So this is the table we want. Let's say show table data. Okay, here. So these are this is my access control list. I only have access to user 1 for a few customers. So now if I'm here and I hit refresh to reload the customers, what I'll see is that only a subset of the customers are listed. The client is asking for, give me all the customers. It's just that the customers that you get to see, the definition of all the customers for this particular user is this subset. And the important thing is this thing forms a policy in that no matter how you land on the customer list, which URL or which query you write, the moment you touch the customer set somehow, we will inject this policy always. So there is no way around it, which is a nice, simple way. You cannot forget to hook it up in a particular place. Once it works everywhere. And of course, so I have 5 here. If I go here and let's delete this guy, so I should have 4 now. I'll click refresh, and now I have 4. So I have now I have access control going, and I can add and remove users. You can imagine like an admin console that adds and removes these little records from the database. This is also very efficient because if you look at this is actually a link expression. It's a expression tree. And what we do is we don't evaluate this on the Astoria server, on the data services server. What we do is we compose it as part of the bigger link query that we're building, and we ship the whole thing into the data source, be a database or whatever. So this runs at database speeds. This one in particular is pretty fast because you can have indexes over these things and you get an efficient join going. So this is a very efficient way of doing this. Now, of course, now I restricted the customers but not the orders. So even though you may not be able to see a customer, you can see the orders for that customer. So let's, for example, let me show you this real quick. We had, I think it was 53 here. Nope, 52, maybe, there. So let's go to 52, which I'm hoping is this guy. And let's take this ID, and let me address this sales order. So sales orders, blah. So I can see the order here, and you can imagine any application being able to see the order. So if I remove access to the customer, I can still see it, because I set up a policy for the customer, but I didn't say anything about how to treat sales orders. So let's apply the second half of our policy that says, I can only see the sales orders for which I actually have access to the customer. And this actually repeats the same pattern. So I have a query interceptor of sales orders. And this is also an expression, a function of, this time is sales order, and Boolean. And this is on query orders. So what do I want to do here? I want to find out the user, just like before. So I'll grab this piece of code. And now I want to write another predicate that says, given an order O, what I want is all of the orders for which the customer, and I get to use the navigation property we generate, has in the user access list any entry where the record login matches the username. So now, what we're doing is, again, this is a predicate that is being translated and pushed into the database. So this is just, we added one more join, you can imagine, into the query, but this is still as efficient as the other one, and also forms a policy that applies regardless of how I land on sales orders. So if I come back here and hit refresh, I get an error because this doesn't exist, and the browser is actually acting funny, but there you go. So you actually get a 404. This item does not exist for you, right? So it's undistinguishable from an item that actually did not exist at all in the database. It's just that you cannot see it. And of course, if I give access to the customer, you will actually see this order again. So it's a very slick way of having a very efficient access control policy that is driven by the data and the environment, in this case, the login name. So the last thing about access control is, I talked about how to do, this is read-based access control. By extension, also, we don't let you modify anything that you can't read. So first thing we do when you modify something is we go fetch it for a number of reasons. So if we fail to fetch it, then you wouldn't see it. But it may happen that maybe because of the role I'm into or something, I may be able to fetch things but not modify things, or maybe do certain modifications. So we have this other concept called a change interceptor, which you can think of it as the opposite of a query interceptor. So I can create one for orders, for example, and change interceptors look like this. They're void, and we can call them on change order. And they take the object you're operating on, maybe sales order O, and the operation that is being performed. We'll call it update operations. So what I get to do here is I get to validate whether the user can perform a certain operation. For example, I could say that a certain user cannot modify things, so you can only add. So I can say if the operation is update operations.change, and then here I can throw new data service exception, and I can put some error here and some error message. And throwing an exception stops the operation from happening. Of course, you can imagine a more sophisticated thing there where, based on the user ID or the user role, you can choose to stop the user from performing certain operation or not. I'm going to remove this because it's not that interesting. We'll do more on this in a minute. So the last important thing about this is that this works regardless of the tool you're using. So this works on the Silverlight client, certainly, but this will work on any other client that is accessing these URLs. So you do it once on the server, and you have a very nice interface that will do the proper filtering without any artifacts on how you pass information or how you retrieve information that has been subsetted for your access rights. All right, so we know what the service looked like. We now gave it authentication, and we gave it an access control framework. The last thing I want to do with my service is, actually, let me recap on this first. So to do access control, query and change interceptors are sort of the primitive operations you have at hand, and you build from there. The query path in particular is composition-based, which means we push down these queries to the database for efficiency. And you can imagine doing things like role-based access control, you can even use the roles support that is already in the membership provider and the profile service in ASP.NET. And you can also do very granular, row-level security on a per-entity basis using techniques like the one I just showed for access control lists. So now that we have the service in the right shape, how do we add non-trivial behaviors? Like so far, we support simple CRUD operations. Let's say we want to do more than CRUD. So how do we introduce operations without breaking the uniform interface? So let's go back to Visual Studio. And what I want to do here is, first let me illustrate like the benefit of keeping the uniform interface. So I'm going to go back to Silverlight. So here are my customers. This is the customers I get to see. Let me for 1 second remove the restriction I had before on my interceptor. I'll re-enable it later, but I want to show you a simple example. There. So now I should see all of my customers. Up or not. Oh, it helps to comment out the right interceptor. There. Second try. There you go. So far, we saw how to operate on Visual Studio. Let's say I want to support doing inserts from these clients out there, and I want any client to work with my service. I mean, maybe part of my value proposition is that anybody can talk to me. So I'm going to create a customer using curl again, just to show that the extreme case probably is, again, less painful for your scenario. So user ID and password. I'm going to send something. So the content type of what I'm sending is application JSON. And I need to say which data I'm sending. In this case, I'm sending a customer. And the one mandatory field in a customer is the company name. So I'm going to say company name. And we can say mix demo. I could put more information there. I'm using the JSON syntax in this case. And then finally, where do I post it? Well, I post it to bikes.svc/customers, which is the container for customer objects. And if I didn't forget anything, I get the response from the service, which replays the customer for me. And if I go here and hit refresh, I should have like a mix thingy somewhere. Somewhere, there. So I just interacted with the service with like a random library out there that has like, I mean, as low of a barrier of entry as it gets. So now let's take it to the next step. I want to keep this barrier low, but I want to have behaviors that go beyond CRUD. So I want to implement this functionality. Let me show you. Let's grab a customer, this guy. So see the status of this sales order is the draft. Our examples tend to oversimplify sales orders, and this has become the canonical example. In practice, you don't just create a sales order and you're done. Usually, it takes a while for someone to cook up a sales order. If you're a salesperson out there, you negotiate with the customer, adjust prices, add and remove items, and you keep saving from time to time. And there is a point where you're ready. Similarly, if you have a shopping cart, you can think of the shopping cart as a draft sales order that you're preparing, and maybe you snapshot the prices and all. And then when you're done, you submit. And when you submit, you recheck the prices, you make sure you have inventory, and you kick off the fulfilling process for the order. The question is, how do you do that and maintain the RESTful interface? One of the key things is that you don't want to have custom methods, because custom methods are not understood by the intermediaries in the system. So proxies don't know what to do, firewalls don't know how to interpret it. So in general, you sort of break the RESTful abstraction. So what I want to do is I want to support having draft sales orders, and then I want to support switching it to ready mode. And when I switch it to ready, I want to enable price rechecking, order fulfilling workflows, and so on. So, and this is what I want to happen when I click the finalize button. Let's implement that on the server. So the way we're going to implement this is, actually I can re-enable this now. We're going to use a state transition. So what I want to know is when somebody updates an order and changes it from the draft state to the ready state. And if that's the case, I detected the transition I'm looking for, and I want to kick off my activity. So first thing I'm going to say is if the operation is change, let's say you don't actually, for the sake of simplicity, you don't create orders in anything other than draft. I could validate here that the order is always draft when you create it. And so let's say we only care about change for now. And what I want to do is I want to compare it with the one I know of. So I'm going to go query for the original version in the database. So I want to say sales, actually I should say var. The original order is, and I actually get to use, this is original order, let's put it right. I get to use I need to get to the same session that the system is using to talk to the database. And we expose that to current data source. So current data source represents my context. And here I can simply say sales orders. And what I'll say is where order is equals, or sales order ID equals O.sales order ID. So is it the same order? The other thing is, at this point, we're sure that we are not modifying an order that you cannot see. But if you could see any order, you may want to also join with the access control table to verify if the access control maybe has a granular thing that says read only, read write, or something. In this case, I'll ignore it because all I want to know is make sure that I can see it, and that was checked already. So I'll just say select original order. So now the key question here is whether there was a transition between the two. So what I want to say is if the original is in, actually it was too optimistic here. I need to say this, and then say first or default. So if the original is not null, meaning I found it, I can say if the original dot status is draft, so I started on draft, and the order that I got, dot status, is ready, so somebody changed it from draft to ready, so I know that here I can say process order, maybe pass the order O, and process order is some function that I'm not going to go too deep into implementing. But you can imagine something where what you do is maybe recheck prices and start fulfilling workflow. And I only at this point, this becomes regular business logic, right? So the important thing is I detect that in my service level concern, and then I just kick off a regular function, and you can imagine modeling that using the regular business logic infrastructure. So the nice thing about this is, first, the way you model this is using a state transition. So you simply fetch a resource and change the state. For example, now I can use my curl client and simply say, look, all I want to do here is I want to take an order and change, instead of the company name, I want to change the status field to ready. And bang, that will update the order on the server, start the workflow, start the rechecking of prices, and so on. So I don't need to know about custom methods or arguments or anything. I can just act on the state of the resource. Even the Silverlight implementation, if we take a quick look at it, what it does, let me actually find it. When you click the finalize button, what we do is we find the order you have at hand. If it's not, we'll recheck this in the server, but if it is not draft, we'll fail. And otherwise, what we do is we take the status, set it to ready, and then call begin save changes to submit the change to the server. So if I want to have a more function-oriented interface on the client, I can have a function that does just this little step. But the important thing is the behavior itself at the service interface level is exposed in terms of resources rather than the custom function calls. So why is it important? Yeah. So custom methods break the uniform interface that is sort of one of the key elements that bring the value of RESTful systems on the surface. So we don't want to be too hardcore about this, and the reality is that sometimes you do need them even in a RESTful system, and when you do need them, we have a concept called service operations that allows you to create a custom operation. My recommendation, though, in that space is if you can model your system in RESTful terms, great, you can use this. If you find yourself having all custom service operations for everything you do and nothing goes through the regular uniform interface, then as data services is not the tool you're looking for. Either the system needs another perspective or the tool is the wrong tool and you need something like the WCF framework, which has great support for custom methods through the SOAP stack. So if you do model your interface in terms of resources, then you can imagine this mental process where you turn what would be function calls like process sales order into resource state transitions, like for example change the order status to ready, and then use the change interceptor framework to actually perform non-trivial behaviors on the interface beyond just access controls and so on. So this part of the talk, everything I covered works today. This is based on the current shipping version of the data services framework, which ships as part of .NET 3.5 SP1. For the remaining of the talk, I wanted to spend some time talking about our plans, both short-term and longer-term. And there are a few things I can show, a few things I want to put the bug in your mind to see whether this is interesting, is useful, and I would love to hear your feedback after the session or email or something around what do you think and whether this aligns with the problems that you're facing when you're building this kind of applications. Let's start by talking about the new version of AD.NET Data Services. So as of this week, we are announcing the version 1.5, the second iteration of the AD.NET Data Services Framework. We're really excited about data services, and one thing that happened was we got a lot of feedback from customers. And as any V1 product, there were a lot of things that folks were like, oh, this is great, but if we had this and if we had that, we could use it, and this is missing. So we got this mix of everybody liked it, everybody wanted a little bit more. So we did a fast iteration, which is this is the first CTP on over the existing framework. So this works on top of .NET 3.5. And we're going to move fast. We're shooting for shipping the final version of this around this fall. The things we did in this intermediate release, we focused a lot on the capabilities of the service. So we did things like row count, which is kind of a funky thing, or a funny thing, because you build this big, complicated product, and at the end, you need to decide when do you stop building features. And we said row count, we could probably live with row count without it for a version. And not everybody agreed, let me put it that way. So we got a ton of feedback. It's like, hey, how do we do UI? How about scrolling and so on? So it's like, come on, just do row count. So first thing we did is we did row count. And so I want to show you just 2 seconds of row count. But what I want to highlight in the process is this is so far it's a 1.0 application. So it's a data services 1.0 app. I want to convert it to a 1.5 app. What we did is we renamed the assemblies because we're replacing, we don't want to replace the runtime DLLs with custom ones that are a later build, because we want to make sure that if you have a production system, we don't mess with it at all. So what we did is these DLLs have different names, but everything else is the same. So if you want to upgrade from one to the other, what you can do is you go to references in your project. I have system data services here and the services client. I'm going to remove it. Yes. And then I go to references and bring up the add reference dialog. And I have the CTP1 installed in this computer. So in addition to the system.data.services DLL, now we have Microsoft.data.services, which are literally parallel assemblies to the other ones. Now, we changed the assembly names, but nothing else. So if I do build after replacing the binaries, build just goes well. And in fact, everything should work. And just for the effect, I'm not going to close the client. You can imagine these being clients that you don't even control and are out there hitting your service. And things will just continue to work. And these things are not perfect, but we're making a lot of effort to make sure you have the most smooth upgrade. Now, of course, we did roll new features, and the idea is you can enable incremental features as you see fit. Just to toy around for 1 second on this, so this is the list of all of the customers. Remember that the access control thing is kicked in, so it's only the ones I can see. So if you want the count of them, we have a magic segment now. You can say /count, and that gives you the number. So very, very simple, nothing complicated, and I'm sure this is a very small number, so let me do this. So whatever, it's a 4. And of course, if I go to Visual Studio, go here, open the database table, wait for the query. If I add myself another customer and come here, this 4 becomes a 5. This is just the number of rows. And of course, the number of rows applied with all the policies. So it's the number of rows of the customers I can see. And also, everything else in the URL syntax works. So I can still say, for example, filter, and I don't have any interest in field to filter. You can imagine this being the state or something. In this case, I'll just filter on the customer ID and say, I want all of them that have a customer ID greater than 10, and I get a smaller number. So I get pretty flexible. The last thing about count that is cool is that sometimes you want to fetch the first page of a feed and the total count, and you don't want to do 2 round trips to do this. This is nice if you want to only know the count. But if you want to render the first page and have compute the next links, you don't want to do 2 round trips. So we have this thing called inline count. When you do inline count, we give you a feed just like we will give you otherwise with all the entries. But also, we give you a count element at the feed level that has a total. So in a single hit to the server, you fetch the page you want and the total rows in all the pages. So it's kind of an optimization. And of course, we'll build client API to make all of this funny looking XML disappear, and you don't have to deal with it if you don't want to. So in addition to count, we did feed customization. Actually, I want to show you that, so let me switch back. And I promise I'll stop switching. So if you take something like sales orders, and I'll say top just so we don't retrieve too many, although we have the constraint there. So we get this XML. Most people that don't do XML for a living don't actually have this funny looking view, have this other view which caused trouble on my side of things before. So when you access a feed, what you get is a feed view. Of course, in Data Services 1.0, the feed view is not really exciting, is it? Like, there's nothing here. Like, no title, no nothing. And the reason for this is that there's nothing mapped to the standard elements. In the 1.5 version, you can actually map things. There is a way of annotating with metadata if you want certain fields of your entities to map to standard elements of the Atom feed. So as a very, very simple example, if I access the customer set, what I did here is I mapped the title to the company name. And you can map like the summary, author, whatever, like all the standard fields, or almost all the standard fields you can map directly. So you get to produce a feed that, the interesting thing here is it's a good looking feed for a feed client, but at the same time, we propagate enough metadata such that a computer client, like say the Silverlight client we have at hand, knows how to undo the mapping and still treat it as data. So you get full data fidelity, and at the same time, you get cool feeds out of the system. The other thing is we did it so that you can also map non-Atom elements, like random elements. For example, there is a common micro format called GeoRSS. You can actually put GeoRSS latitude and longitude. You can map them to fields of your entity, and now you can take the feed and map it into a map or something using a mashup tool right away. So it's like a very flexible way of representing feeds. We also did a bunch of other work. We did great blob support. Our blob support was just okay. Server-driven paging, which is a way of controlling how much data flows from the server. And one of the favorites is we did a lot of work on data binding. We implement all the data binding interfaces now. So if you are in Silverlight or .NET, you can choose your objects to implement iNotify property change, iNotify collection change, and so on. So this should save folks a lot of work when using the AD.NET Data Services client side. We also did what we call a fancy provider framework. This is if you need a lot of control over what you're doing. In addition to the simple hookup that we had before, now we have an advanced hookup where you can control everything. To give you an idea of what I mean by everything, the Azure Table Service, so this is our cloud offering for storage, actually uses these very same bits to run their operations. So as I mentioned before, this runs without overwriting the 1.0 runtime. So that was Data Services 1.5. We're very excited about this. This is on the web already, so you can go there and download the bits and try them on your box. The other thing that I found very exciting is also this week we put out there preview 4 of the new ASP.NET Ajax toolkit. We've been iterating over this toolkit for a while, so it's a large, nice, mature toolkit. And one of the things we've been working on is to have an integrated AD.NET Data Services client that works directly in your Ajax application. The Ajax client has been out for a while. Maybe some of you guys tried it already. If you don't, I highly recommend it. It's a piece of cake to use, very nice experience. But in addition to the programmatic client, the Ajax folks were working on this thing they call templates and data binding features. They basically brought in the concept of data binding and templating into Ajax. And this is a pure Ajax implementation, has no dependencies on the server side. Of course, we like it better when you use ASP.NET, but you can choose not to. And the idea is that if you have a data source, you can bind and have templates and render them, and I'll show it in a second. And the best thing of all, it works together. So you can put the Astoria data source and the templates and the binding, and it actually gives you a very, very nice experience. Let me actually show you this real quick. So here's I could be using the script manager because I'm in ASP.NET, but if this was a plain web server, in this case I have an HTML5, I just added the pointer to my JavaScript files. So check out this code. What I have here is a couple of namespace declarations where we are mapping names to JavaScript, basically object names. And then I have this thing where I want to say, I want a list, and so it's a UL, and I want to attach a data view object to this list. And I want it auto-fetching. That means I don't want to call any code to fetch whatever I'm pointing you to. And we can plug in data providers. So this could be just a bunch of JavaScript objects in memory, and we'll just render them. Or we have a provider for web services, and in this case, a provider for the AD.NET Data Services endpoints. And in the provider, you can give the file name. In this case, I'm using the same one I was using for Silverlight. The operation is just a URL. This is a relative URL, so in this case, I'm fetching all of the sales orders. And you can tweak things with parameters. In this case, I'm prefetching the order lines and the products for the orders. So I'm basically doing round-trip optimization. I don't want to go back and forth too often. And I can even say, and by the way, I want selection. So whenever somebody selects an item, just change the CSS class to this new class. And the final step is, what I have here is a template of each line item. The template says, I want a line item, and I want it to look like this. Order, colon, and you can see this SAML-ish syntax, which means bind to this property of the object I'm iterating over. So very, very simple, borrows a lot from XAML to avoid inventing stuff, and it actually gives you a very powerful thing, because if you do this in JavaScript, you hate these loops where you just loop, attach the HTML together, and then at the end you just stick the value inside a div or something. And this saves you a lot of work in the primary paths. There are fancy things you can do. I mean, this works. If I run this piece alone, it will just work and render what you would expect. The other thing you can do is you can do master detail pretty easily using the same infrastructure. In this case, I created a table, which is also a data view. And look at the data item. So I'm using binding syntax to bind to a property in another object. So I'm not going to a network. I'm going to the selected data property of orders, where orders is the data view I have up, like before. So effectively, I'm binding to a property of another object in the page. The effect of this is the selected data property. What that means is, as the selection changes on the upper grid, the lower grid gets bound to the new selection object. So effectively, you have like master detail navigation already done, and it's synchronized and all. So let me actually show you in the browser what this thing looks like. And this is, by the way, so this is all the code that is in the page. Like the rest is CSS files, CSS style sheets and things like that. So if I open this in the browser, well, I was supposed to remove this, but anyway, let's log in. So I get my bikes, and I get the sales orders here. And if I click on a sales order, I get the sales order line. And all of this is working with only the XML markup I just put in there. So we hit the service, bring it back, and render it. We can, if these were text editors, you can edit things here. We even track changes, so if you have the same thing displayed in multiple places, it will be in sync. And then once you're done, you call save changes, and we'll push all the changes back into the data service. And in fact, if you're using a data service from AD.NET, we'll even do batching. So we'll collect all the changes and send them to the server in a single go. All right, so short term, 1.5. We're also preview 4 of the ASP.NET Ajax toolkit. Let's keep moving in time a little bit. So SQL Server Data Services. So how many of you are familiar with the with SDS or SQL Data Services? A few of you, great. So as part of the Azure offering that Microsoft has for providing cloud services for writing applications, one of the key aspects of writing an application is persistent storage. We have a number of offerings for storage depending on your needs. We have a queuing system. We have a blob store. We have a simple table model where what you do is you have effectively dictionaries of name-value pairs. And what we are announcing this week is an enhanced form of SQL data services where what we have is a full relational store running on the cloud, running on the Azure system. That means that all you know about SQL just works. All the programming model that you have just works, and all of the APIs that you're using to hit your local database work just the same when you're hitting the cloud. So you can imagine a couple of words for this. One where you hit the database directly from outside of the web. I'm not sure that's going to be that common, especially at the beginning, because we use the database protocol that we always used, which tends to be blocked by firewalls and stuff. But I think the more common case is the other one where what you have is the higher one here, which what you have is the web application running on a web role in the Azure system, the database running inside Azure as well, and that's a fast connection using our database client server protocol, and then you have the clients outside. So it's a great way of hosting applications in the cloud without churning either your code or your know-how on how to use this system. So why am I talking about this? A lot of questions that we got is, well, now a lot of people were using the REST interface over SQL data services. So what if I want REST access to my data? Now I have a database, not a REST thing. Well, there's nothing that prevents you from running data services on the web role. And just use the entity framework and point it to the database. And now you have a REST interface. And not only that, you have a REST interface you fully control. So all of the techniques I discussed today work just as fine running inside the Azure system, and you can expose a RESTful interface over your data right there. All right, so let me keep moving on. So the last thing that I wanted to talk about that is in somewhat near future is something that we announced here at MIX also that's called .NET RIA Services. So before I get into RIA Services, let me talk about what we hear around the requirements from our customers. There are two things that we hear a lot. On the server side, what we hear is, if I'm building a data-centric service with relatively low business logic, the interceptor model works well. However, if I'm writing a sophisticated application that has a lot of business logic on the server, the interceptor model doesn't scale in the development process very well. There is no proper separation of concerns there between my business logic and my service concerns. And also, I can only have so many interceptor functions in a single data service class. The other challenge that we have is on the client side, and it's along the lines of, well, great, you put the data on the client, now I want to validate it, and I want to have integration with the data source objects and with the UI widgets and so on, and that's another sort of common ask. So it turns out that as we were hearing this, the folks in the .NET RIA services were building a framework to address these very same scenarios. And what they needed was the other way around. They needed a way of shipping data back and forth and formulating queries and updates and all that stuff over RIA applications. So what we ended up doing is we said, well, perfect. I mean, this is a classic layering problem where what we will do is we'll layer the whole programming model of RIA services and the domain service concept on top of the data services framework. What that means is data services under the or RIA services under the covers just uses the data service framework to exchange queries and data and so on. And by extension, what that means is not only you can build RIAs with this thing, which makes it a piece of cake, but also you can author RESTful data services using the business logic model that comes from the RIA services framework. So now we have an opportunity to address all of these requirements that we get from customers, and at the same time we have the benefit of the sort of UI framework and business logic and so on that is integrated not only with data services but with other parts of the .NET framework as well. So I got a lot of questions about what does this look like. So I don't have a lot of time, but I wanted to show a brief example. So you probably have seen this before. This is a regular data service class. Usually when you create a data service, say the catalog service, you say this is a data service of catalog, and catalog is your data source class. A data source class can be an entity framework context, a link to SQL context, an Hibernate context. It could be not a database. This could be the Azure backend system, or who knows, like a custom thing that this is open for everybody to implement. What we wanted to do from the service perspective was extend this metaphor and say, if you modeled your business logic as a domain service, you can have the domain service be the data source for that data service. So what I have in the lower part of the screen now is what we call a domain service. And the domain service encapsulates the business logic. And I kind of shortened it up. You can imagine more things going on there. But the idea is this is a domain service with all of my custom methods for updates and for queries and so on. And I can just, instead of saying catalog is an entity framework class, for example, I can say catalog is a domain service. And everything else just works the same. So you have the same RESTful interface, same interaction model, and so on, except that now we have a clear-cut separation of concerns between your business logic and your service-related aspects. Of course, there's going to be scenarios where you don't have any service-related concerns and you only care about the business logic. And in that case, we're not going to force you to do the thing on the top, and we have an attribute that basically says, do whatever, do the right thing, and we'll just, we'll take care of it. And all we do under the covers is spin up one of these on the flight. But if you want full control over it, you have full control by layering it this way. Okay, so final slide. I got a lot of questions during the session. I was actually not going to talk about this, but I got so many questions here at MIX that I decided to put a slide on it. A couple of weeks ago, we talked about Astoria Offline. Astoria Offline is, the vision is very simple. We want to enable services to be sync-enabled, which is very different from databases being sync-enabled. We want services that are proper for the web and that are natural for the web to be something you can use for synchronization and for offline applications. And we want to do it such that it's a smooth end-to-end experience from within Visual Studio to create servers, clients, and to attach them together in a synchronization relationship. So there is a CTP out there. You can download it and play with it. But the one thing I want to highlight is this is an exploration effort. It's not a product. We're looking at the space, and we're experimenting with this thing where we're doing our exploration publicly. Typically, we would do this under the covers, and then we go like, "Chanan," and then it works or it doesn't. So we're saying, look, we think the space is very interesting. I personally think this space is very interesting, but we want to know more about scenarios and things like that. So we're putting the bits, which is a prototype, out there, and we want to hear if this is something you guys are interested in, you will do more, if it's the right approach or not, and so on. So if you're interested in it, check it out. You probably want to do this in a virtual machine or something. This is not the kind of thing you want in your primary computer. All right, with that, so I wanted to summarize the talk in 3 points. One is the data services framework allows you to build fully featured RESTful services that are true to the principles of the REST architectural style. You can model behaviors, business logic, access control, the whole thing using a RESTful interface. And you have the right escape hatches to control things when that's not expressive enough. Second, we are extending the core of data services to provide all of the basic functionality that you need. And we're trying to do that as fast as we can because we know folks are looking forward to this second iteration. And finally, as we're done with this 1.5 release, our next sort of area of focus is around, especially around nailing the programming model aspects. And we want to have a solid server-side and client-side programming model that provides an end-to-end solution, both to author open-wide RESTful services that are accessible to everybody on the web, as well as for building rich internet applications that use the Microsoft stack end-to-end. And with that, I want to thank you very much for coming, and I'll take a few questions if you want to stick around. Any questions? Yeah. Yeah, just yell.
Yeah, repeat. The biggest concerns I have about RESTful services is the lack of a contract. I realize you're on top of the HTTP spec and what have you, but is there anything down the road that we're looking at?
Perfect question. The question is, a worry is the lack of a contract. Of course, there are no operations, so we cannot do a WSDL kind of contract, but it is about structure, so we do have a contract that is expressed in terms of a structure. You know when I did the add service reference in Visual Studio and we generated client proxies? There is nothing proprietary about that. There is no secret sauce. What we do is every service endpoint, let me go to bikes.svc, has a special URL that everybody knows about within the system called $sign metadata. And if you fetch that guy, you get an XML file that... I can't see what you're saying. Oh, sorry. So again, so there is a $metadata endpoint, and you get an XML file, and the XML file has all of your entity types with its properties, and also the sets that contain those types, and so on. So it's enough information that you can tell the shape of every resource in the system and the top-level URLs for every entry point in the system. This, combined with the convention for URLs that we use, allows you to literally navigate the entire data set exposed through the system. And we actually, like when we do code generation, there's no magic pass at the covers. All we do is we pull this document from the server into the client, and then our client takes this document and produces types. And it's exactly a schema endpoint. And the interesting thing about this also is that this is published. So anybody can pull this document and write their clients in any language they want. And if you don't want to be contract-driven, some people don't, there is enough information in the instances to at least guarantee full fidelity round-tripping. So it's entirely your choice. If you want to be contract-driven, you can use the contract. If you don't, you still have the opportunity to have full fidelity retrieval and update within the framework without ever looking at the metadata. All right, so I'll be hanging out here. So if anybody has any other questions, I'll take it. Thanks.